Hello everyone, today our topic is optical switching. And first let's talk about optical fiber. Optical fiber is made up of three components which are shown in the picture. And the most important thing for the optical fiber is the total internal reflection. And generally the two common types of fiber which are single mode fiber and multimode fiber. The multimode fiber is more expensive and have the wider diameter than the single mode fiber. And the multimode fiber usually used for short distance to communicate, and the single mode fiber is also used for the longer distance communicate. And the wavelength division multiplexing, which is short for WDM technology, is the key function to the optical switching. And we can see in this picture that numbers of different wavelengths are combined together then transmitted through the fiber line. And while on the receiver side, the demultiplexer separate different wavelengths from each other. And next, let's talk about the optical network used in the access networks. And there are two alternate network designs that makes fiber broadband connection possible. So it's the active and passive optical networks. And in the right, it is active optical network. It utilizes electricity power switching equipment like routers or a switch aggregator to manage signal distribution and direction to the correct end users. These switches open and close to ensure that the outgoing and incoming message are going in the right direction. And comparing to the active optical network, the left one, the passive optical network, does not have electrically powered equipment and rather make use of optical splitter to separate and connect optical signal that moves through the network. And both of them have their advantages and disadvantages, only depending on their purpose. Next, let's talk about optical switching technologies. There are many technologies, and today we will mainly focus on micro-electromechanical systems. The MEMS technology is a precision device technology that integrates mechanical elements, sensor, actuator, and electronics on a common silicon substrate through microfabrication technology. Here you can see two types of MEMS switches, and the left one is a two-dimensional MEMS switch descriptive picture, and the right one is a three-dimensional descriptive picture and what it will look like. Moving to the wavelength routing network, the idea at the basis of the wavelength routing network consists of maximum reuse the same wavelength, and it is motivated by the wavelength division multiplexing technology, and it actually elevates the pressure on the network. And next, let's talk about optical multiplexing and demultiplexing techniques used in optical switching. And basically, we have an optical add-drop multiplexer which could drop any unwanted wavelengths, or we can add any new wavelengths at any time during transmission. And for the demultiplexing, there are four ways to achieve it. So the first one is using refraction. A parallel beam of polychromatic light impinge on a prism surface, and each component wavelength is refracted differently. And this is a rainbow effect. In output light, each wavelength is separated from the next by an angle, which could realize the demultiplexing. And the second is using diffraction. So when a polychromatic light source impinge on a diffraction grating, and each wavelength is diffracted at a different angle and therefore to a different point in space. So using a lens, these wavelengths can be focused on individual fibers. And the third is using interference. The waveguides are connected to cavities at input and output. When the light enters the input cavity, it is diffracted and enters the waveguide array. And the last one is using filters. So by positioning filter consisting of thin films in the optical path, wavelengths can be demultiplexed, and each filter transmits one wavelength while reflecting others. By cascading this device, many wavelengths can be demultiplexed. Okay, and all of these are just part of the optical switching, and thanks for watching.